Welcome to my V6 engine in Inventor demo. Off to the left are timestamps for given topics. At the bottom, the progress bar can be used to skip around. What got me onto this project? Well, spring 2020 was on approach, and COVID blew up. The ski season came to an abrupt end, dinner out with friends wasn't advisable, my plans to go camping were cancelled, and the state was largely under lockdown. I asked myself what to do with this free time. I figured it might be fun to dip my toes into a new piece of software. I went with Autodesk Inventor. Being someone who learns through application and doing, I picked up a tutorial for SolidWorks. SolidWorks is kind of like the little brother of CATIA, my bread and butter at work. And I wanted to experiment with SolidWorks' cousin, Inventor. There would be enough different that I could challenge my ability to adapt. Is my attempt to follow the tutorial I just mentioned. A V6 engine with the majority of its functional parts. If I peel back some of the layers, we can dive into something I find exciting, the constraint and part relationships. Most of these objects are constrained together face to face or centerline to centerline. This allowed very fast assembly of the parts. A few items have been allowed degrees of freedom. Rotational elements like the crank and camshafts are allowed to rotate. Some items, like the piston heads, are allowed to translate along a centerline axis. This allows the crankshafts, pistons, and pulley to interact as shown in this animation that will play for about 10 seconds. Some elements have special transitional constraints. The rocker arm is a good example. It has rollers tied to the surface of nearby cams and rocker arm springs. Using transitional constraints, this allows the camshaft system to interact with all components including the cams, rocker arm springs, and valves. I was appreciative for having a YouTube demonstration to give me some of the specific dimensions for this engine. It had a few bad instructions I had to troubleshoot though. The intake manifold had to be mirrored to get it to line up with the offset of the cylinder heads. The exhaust didn't line up with the cylinder heads. The camshaft retainer didn't facilitate the valve cover. The diameter of the crankshaft didn't match the bushing or the pulley for the belt. Anticipating issues with how my system might handle all of these constraints, I held off on applying fillets to a lot of edges that should use them, which is the perfect transition to the next topic. Project improvements. I would have filleted items ahead of time. Waiting until after constraints were set was a mistake, because constraints are looking for surfaces and axes that are redefined when I end up adding fillets. Given an unlimited amount of time, I would come up with a trigonometric relationship for the phase angle of the camshaft as it rotates and the angle between the rocker head to the top of the cylinder head. There are three things that I really like about Inventor. The first one is its systems of constraints. If you can draft it, you can dimension it to restrict your support. Second, its file structure makes sense. You have parts that are your most basic components, like the camshaft or valve cover. Then you have assemblies that collect your parts, like the engine file itself. But you're not restricted to just one assembly. You can have sub-assembly collections of parts, like the piston, which has the head, rod, pin, and rod cap, and it lives in the engine itself. Third, its 3D process is based off of 2D basics. You create a 2D sketch, and then you either extrude, loft, or sweep that profile, and then create your 3D shape. This concludes my Autodesk Inventor V6 engine demo. Thank you for bearing with me. If you have any suggestions or questions, please feel free to contact me through my Contact Me page or the email in the description of this YouTube video.